All right, everybody. Today we're going to talk a little bit about what we call marginal analysis. And you can do marginal cost, marginal revenue, marginal profit. There are some other things, but those are the big three that we're going to look at as we go through. And so, normally, if you look at in the business world, we usually look at rate of change. It's one of the things that we look at a lot. That's how we start looking at derivative and things like that. We'll have stuff like, hey, there's a cost function, C of X, because mathematicians are really not that ingenious in how we name things. C for cost of X. And we'll say, okay, there's a cost function, then the marginal cost is C prime of X. Okay, so using that prime notation that we got earlier from looking at derivatives with the apostrophe up there. Okay, if there's a revenue function, and again, R of X for revenue, then there's a marginal revenue function. And we use R prime of X for the derivative of the revenue function. So using some of the rules that we had that we looked at last time, if we know that the profit function, P of X, is equal to revenue, oops, not prime, revenue minus cost. Okay. So in other words, you look at the amount of money that we have coming in and you subtract off the amount of money that you have to use. Maybe it's to pay the electric bill or the rent, or maybe these are employees, salaries, things like that. All the money we get from selling our products minus all the money that we spent to make those products, and that's how we get our profit. Okay. So again, P of X for profit. So if you wanted the derivative, the marginal profit function, then we know from our rules last time that because I have a sum or difference of two functions going here, excuse me, these polynomial guys, these functions, but there's a sum or difference going on, that I can just take the derivative of the first one, a minus, because there's a minus in the formula up here, the derivative of the second one. And that is how, taking the derivative of the revenue minus the derivative of the cost, that's how I can get the derivative of the profit. So I don't have to do the whole thing all at once. I can take it in pieces using that sum or difference property that we looked at before. Okay, so the way we use this a lot of times in, you'll see it in economics, you see it in a couple of different business classes, um, if we want to know the price or the revenue or whatever, if we want to know, I'm going to go with cost of creating one more item. Okay, we want to know the cost of creating one more item. So it's just a single item. It's not the total number of items that we're creating. It's just one more item. What we see is you would find the marginal cost function. Okay, for the item before the next. So in other words, if I want to make the next item and I want to know how much that's going to cost me, then I'm going to use the what we call marginal cost function. I'm going to take the derivative and I'm going to find that rate of change. Just like we saw before. I'm sorry, I'm just sleepy. I'm going to take the rate of change, the marginal cost function, and I'm going to look at the last item that I've created and the item before the next guy. So we want to know how much is the next guy. So I'm going to look at the one that I have and figure out, okay, what's it going to cost me for one more item? And again, it's important to know here, I'm saying, the cost of creating one more, but it could just as easily be what's the revenue I'm going to bring in if I sell one more? What's the profit we're going to bring in if we create and sell one more item? So it depends on which function I'm using, the way I think about it. So what we're saying is, and I'll get you a hardcore example in just a second, but if you want to know the cost, we're sitting at X. If you want to know, excuse me, I'm so sorry. If you want to know one more item, so X plus one, then what we do is we subtract the cost for all of them. If I have 100 items, I'm going to subtract the cost for 101 items minus the cost of 100 items. So that's without the plus one. And that will give me the cost of the X plus first item. Okay. So that very next guy, X plus one, that guy, you can do it by doing X plus one, the cost of X plus one minus the cost of X. Okay. So let's see how that looks. Here's an example. I know it's kind of hard sometimes whenever we're doing generic. It helps to get like an actual concrete number in here. So this says a company makes fuel tanks for cars. Company makes fuel tanks for cars. Okay. Somewhere in the back office, somebody came up with a function for them. Somebody kept track of all of their costs. So, what are my fixed costs? What are my variable costs? For instance, fixed cost is we also always have to have the building rent paid for, right? If we're in a manufacturing company, basically. But the variable cost could be how much are the lights on? How much water do we use? If we're making fuel tanks, maybe we have to purchase more of whatever the material is we're making it out of. I don't know, probably fiberglass. So for every item, we have to have a little bit more of that material. And every time we have that, that is a variable cost, right? Okay. So somebody in the back office put together a bunch of numbers and followed what our company was doing for years and years. And they think that our cost function is 10,000 plus 90x minus 0.05x squared. Okay. So the first part that we're going to do here is find the exact cost of creating, manufacturing, spell in this class, manufacturing the 501st fuel tank. Okay. So this is where this right here is going to come in. If I want to know the price of just that single item, so not all 501 of them, we're going to use that, but I just want the single item, the 501st item. Okay. If I want that, then what I'm going to do is I'm going to find the cost of doing all 501 of them, and I'm going to subtract off the cost of doing 500 of them. Does that make sense? So I'm going to have to do a little bit of math here. Going to get out my calculator here in a second. So what we're saying is to find the exact cost of x plus 1 minus the cost of x is going to be what we're after. So here we're saying the cost of 501 items minus the cost of 500 items, and that will give me the single item price, cost, I should say, for the 501st guy. Okay, that's what we're saying. So take the total, subtract off 500 of them. That will give you exactly what's left in that gap between these two, which is just that one single item, the 501st guy. Okay, so before I can do this, I'm going to have to do a little bit of substituting in. I need to find the cost of 500, and I need to find the cost of 501. Oh, sorry. I want this equation on there, but I'm gonna have to scoot. Okay, the cost of the 501st guy when the cost function is 10,000 plus 90 times, I'm putting in a 500 everywhere I see an X, minus 0.05 times, again, 500, because it's minus 0.05 X squared, right? Okay. And I'm going to do some of this on my calculator as much as possible. So here we go. I'm going to start at the back, 500 squared times 0.05. That's going to give me this number. Okay. I'm sorry, I didn't do that right. I'm like, why does that look so weird? 500, it put the 0.05 up in the exponent. 500 squared, let's find that number. There we go. Times 0.05. That's better. Okay, so it's telling me that that's a 12,500 right here. And I can also do 90 times 500 and get that number. So what I'm seeing is 10,000 plus 45,000, right? Minus, and that number was 12,500. Okay, so I'm going to do 10,000 plus 45,000 minus 12,500, and I'm getting 42,500. Okay. Now, this next one, put it right there, is the same thing, 10,000 plus 90 times, but I'm looking for the 501st guy, right? So I'm going to plug in for X 501 minus the 0.05 times the 501. Again, be careful how you're plugging in here. Squared, right? So gonna have to do a little calculator work again. Let's see what this is. 90 times 501, 45,090 minus, and 501 squared, let's find what that is, times the 0.05. It's a minus 12,550.05. Okay. So 10,000 plus 45,090 minus 12,550.05. All right. So it looks like 42,539 and 95 cents. Okay. So that's the cost of making 501 of these guys. So what we're saying here is if we take the cost of making 501 of these and we subtract the cost of making 500 of these, the difference is going to be exactly the cost of the 501st guy, right? So the cost of the 501st item all by itself is the cost of the 501 minus the cost of the 500. That'll give me a little gap in there, and I can even do this all by myself, right? $39.95. Okay, that's the exact cost for the 501st item. Exact, like we figured it using the actual formula and everything. Okay, so that's the idea that's going on here. If I was to do this manually by hand without derivatives, like actually trying to figure things out. Okay, so what happens is they want me to, instead of doing it that way, so this was part A up here. Okay, we did the actual exact cost. Instead of doing that, they want me to do it using marginal cost. Marginal cost of creating 501st item. Okay, so this is where we have to be just a tiny bit careful, because what we're saying is we want the next guy after the 500th guy. Okay, so whenever we do this work, we're going to be plugging into our derivative, because we said marginal cost and derivative were going to be the same. We're going to be plugging in the 500. That will give me the cost for the next item, the next guy, which is the 501st guy. Okay, so let's see. Let's go back here. C of x equals 10,000 plus 90 times x minus 0.05 times x squared. Okay. That was my original cost function. Now, what I'd like for everybody to do is kind of pause the video and see if you can find C prime of x all by yourself without me helping. Okay. Using your rules that we went through last time. Hopefully you can do that. And here's what I will say. 10,000 is a constant. The derivative of a constant is 0. Okay. This is actually x to the first power, right? So 1 times 90. I'm going to write it out and then I'll simplify it in a minute. Okay. And then x to the, it's going to be 1 minus 1. That's x to the 0. What do we know about x to the 0? Anything to the 0 power is a 1, right? So that's going to go away. Okay. And then minus, and again, we have an exponent here. So it's just a pretty polynomial. Let's multiply it out. 2 times 0.05. And then remember here what happens. It's x to the 2 minus 1. We got to subtract 1 from the exponent. So it's a 1. We know we don't have to write x to the first power, right? We can just write x. So we've got it. We just need to clean this up a little bit. C prime of x is 0. I'm going to ignore that. 1 times 90 times 1 is a 90. Okay. Minus, and if you're not sure about what's going on there, put it in your calculator. It's 2 times 0.05. I'm sorry. There we go. Okay. And that's just a 0.1. So it's negative 0.1x. Okay. And they're asking me what's the cost for the next guy after the 500th guy. So I'm going to plug in 500. Okay. I'm going to figure out that, sorry, 0.1, get out of the way, 0.1 times 500 is going to move that decimal place just one place, right? So that's going to be a 50. So this is going to be 90 minus 50. And we all know 90 minus 50 is 40. So there we go. We have taken the derivative and plugged in 500. And what we have here is called an approximate cost for the next item. Or as we said, that's the 501st guy, right? Number 501. Okay, so let's see if we like that or not. Okay, by the way, part C in the book says interpret your answer. Okay, so what we're saying is it was really fast for me to take the derivative and then plug in the 500. I got a 40 pretty fast. Okay, when we did it the long way, it took a lot more paper, right? We had to find the cost for 500. We have to find the cost for 501. We had to subtract it, and we had an answer of $39.95. So if we are in a manufacturing company and we want to know how much is it going to cost me to make one more thing, is it worth it? Then I could do it using derivatives pretty quickly and approximate it to $40, or I could do it longhand and take a little bit more time and find it's $39.95. That's a pretty good approximation, right? $39.95 versus 40. That's a 5-cent difference. Okay. That's pretty good. And if I just want to know what's the cost of the next item, making that next item, I probably don't care that I'm off by 5 cents. So normally an approximation is probably pretty good here. Sometimes people don't want approximations. That's when we would do it the long way. Okay, find the exact value to create the next item. But a lot of times they're going to say, use the marginal cost or use the marginal revenue or use the marginal profit to approximate what's going to happen next. So it's use the marginal whatever to approximate the next item. Oops, sorry. Next item. And this is, again, normally cost or revenue or profit. Depends on what I'm given in the problem. Okay. So that's the idea of what's going on there. If you had to interpret that, you would say it approximates the cost of creating one more item, and we'd be okay. All right. So let's see. There's a theorem that goes in this section. We haven't done a lot of theorems around here, but I'm going to go ahead and give it to you. And it's called marginal cost versus exact cost. And I'm doing, again, cost, but it could be marginal revenue versus exact revenue. It could be marginal profit versus exact profit. So here's what it says. And there's one for each of these. This one happens to be for cost. If C of X is the total cost of producing X items, then the marginal cost C prime of X. Okay, again, we read that derivative. Okay, the derivative function will approximate the exact value. In this case, it's a cost, the exact cost. I should put that in there. Of making one more item. And I would say that the biggest problem here that people have is for this, whenever they're doing the derivative, sometimes they'll say, oh, I want the 501st item. So they would put 501 in here. You have to remember, I want the 501st. So I have to use the last item before that, which is 500. Okay. So there you have that. All right. So what this means for us is that C prime of X is approximately the same as C of X plus 1 minus the C of X. Okay, so we can use marginal cost, the derivative here, pretty intertwiningly. And they're similar to each other. We're going to get very close costs, very close profits, whatever. So basically what happens a lot of times in business is people say, oh, I'm going to go with the derivative because usually that's a lot faster to take, especially if I have something that kind of looks like a polynomial. It makes life nicer. All right. So here's you an example. I'd like for you, once I get it put out here, I'd like for you to pause the video, work it both ways. In this video, we're making bicycles. I'm sorry, in this question example, we're making bicycles, and somebody in the back office has told us our cost function is 10,000 plus 150x minus 0.2x squared. Okay, so we're going to use that as our cost function. And there's two parts. One is, or A is, find the exact value. We're doing costs here. The exact cost for 121st item, bicycle in this case. And B says approximate the cost for creating the 121st item using the derivative. Okay. So go ahead and pause the video. I'm going to pause as well. I'm going to work it out. We'll see if we get the same stuff. So unpause it when you're ready. All right. So I hope you spent a little bit of time and worked that guy out. The cost of creating 120 items is 25,120. The cost of creating 121 items is 25,221 and 80 cents. The difference between those, so that will tell me the exact cost for the 121st item is $101.80. So what they're saying here is the exact item in this company to make the 121st bicycle is $101.80. Okay. So it didn't take me too long to do that, but it is a little bit of math. Um, Doing it the other way, approximating it using the derivative, I found the derivative. Here it is. Derivative 10,000 is 0, 150 point negative 0.4x. So this is what I have for my derivative, and then I stuck in 120. Remember, when we want to know the 121st, the cost for that, we put in the 120th to get to the next guy. Okay, so here is me plugging in 120, subtracting it, and I got 102. So here's my approximation, 102, and here's the exact $101.80. The difference there is 20 cents. Probably don't care that much if we just want a good approximation. I mean, if we're doing accounting and this is my tax paperwork, yes, I care about those extra 20 cents, right? But if this is just so I'll have a good approximation of, how much materials I need or how much it's going to cost, that kind of thing, then I probably don't really care about that extra 20 cents in the moment. Like I'd probably care once I got into my accounting. So I would care once I got into my accounting spreadsheets and all that. But right here in the moment, trying to figure out should we make that 121st bike? It's going to cost you $102. That's a good guesstimate. All right. All right. One more of these, and we're going to do one that's not a cost function. So everybody has a chance to play with it and see. A company wants to make and market a new headphone. Okay. Make and market a new headphone. Okay. So maybe it's a new brand or something like that. What they've done is they've gone out into the market. They sent their marketing people, somebody to do some surveys, somebody to try out what the people and the general public want, and they came up with a price demand function. We saw some of these in test 1, price demand function. Okay, so what they say is if you set something at price P, right? Because we're always doing this kind of stuff in math, price is little p, okay? Then you're going to be able to sell the demand for X number of items is going to be given by 10,000 minus 1,000 times P, okay? So that's the idea here. And you can solve for P to get the price and all that kind of stuff if you want it. Did it ask me for the price? No, it doesn't. I'm sorry. I'm trying to read the problem. It doesn't ask me for the price. It just says, what it says is find the revenue function. Okay, so there's multiple parts here. Oh, it does give me a cost function. So they know from their finance people in the back office that the cost function is 7,000 plus 2x. Okay, so these two things we know. This is the price um, for selling this many items. We got to price it here. That's where the market equilibrium is. And here's the cost that it's going to take me to make X number of items. Okay. In this case, it would be the headphones. So part A says find a revenue function. So it's been a little bit since we did this, so we're going to go back and remind ourselves. Okay, whenever we want revenue function, it's generally speaking, the revenue is equal to the um, number of items you can spend here times the P, the number of items you can sell, I should say, times the P. Okay, so I actually do need to find P up here. I'm going to do that in just a second, and then I'll take that and I'll multiply it by how many items I think I can sell. That will tell me the revenue. Okay, so let's do this math. So if X equals 10,000 minus 1,000 P, and I want to get the P by itself so that I can stick it into this revenue function, I'm going to subtract 10,000. And that'll give me a negative 1,000 P. Okay. And then I say, hey, I want that P completely by itself. It's being multiplied by a negative 1,000. So I'm going to divide everything by a negative 1,000. Make sure you do all of your terms. Okay. And then I'm going to end up with P back here by itself. Negative 10 divided by negative 1 is a positive 10, right? And then X divided by negative 1,000. I'm going to go ahead and put that into a decimal place just so we can see it. The 1,000th position is, and it's negative, 0, that's tenths, hundredths, 1. That's the thousandths, right? So 0.001 and the X because it's just sitting there, right? I got to bring it down. Okay. Plus 10, because a negative over a negative is a positive. That's my price function. Okay. That's my price function. All right. So then we say, okay, you've got that. We want the revenue function because this particular problem A said find the revenue function. R of X is equal this guy times X. Okay. And if you didn't notice before, a lot of times with these revenue functions, we end up, and even the cost functions, a lot of times we'll end up with a negative in there. So whenever I distribute this guy through, be really careful as we do that. I made a mistake the other day on my video where I said I was going to distribute, but then I didn't do it. Okay. So this is negative 0.001 x times x is x squared. And then this is x times 10, so a positive 10x. There we go. Okay, there's my revenue function. So that was part A. Part B says, and you can rearrange that. Oh, where's my x squared? Sorry, x squared, right? You can rearrange that if you want. Some people don't like having the negative out in front. I'm going to leave it alone because I like having my x squared out front. I don't care that it's negative, so I'm going to do that. Okay. So what they're asking me to do next, part B, is find the revenue at X equals 2,000, X equals 5,000, and X equals 7,000. Okay, well, we can do that for sure. This is part B. All we got to do is plug in. We've got our revenue function, plug in these numbers, and we're going to do it 3 different times. So we get 3 different answers. So revenue of 2,000, negative 0.001 times the 2,000 squared plus 10 times 2,000 plugging in that 2,000 for the x. Let's see what we got. 10 times 2,000. If you're noticing, I sometimes tend to do this number in the back first. It's because sometimes this is weird in front. I try not to do it, but 2,000 squared, okay, is this number squared, and then times 0.001. It's negative, but a negative times a positive is a negative, so I'm just going to write the negative down. That's negative 4,000, okay? Plus, when I did 10 times 20,000, or I'm sorry, 10 times 2,000, I got 20,000. And we all know 20,000 minus 4,000, that's 16,000. Okay. So the revenue that you think you would make here whenever you had 2,000 items would be about 16,000. Okay. And then keep going. So if you want to pause, you can pause. Make sure you can do these on your own. I've had a lot of students tell me, "Oh, I get it when you do it." Well, yeah, sure, because I'm talking you through it. So if you need to make sure you can do it, then pause the video and make sure you can do it. And then come back. Okay, that's 25 with 1, 2, 3, 6 zeros. So 25 million. 5,000 with a extra zero in the back there. When I multiply that 25 million by negative 0.001, it's going to bring it down real small, right? So negative 25,000 plus a 50,000. Well, that's 25,000, right? Okay. So I'm getting $25,000 there. And then the last one was put in a 7,000. So work it a third time with yet another number. Oops, come back here. The revenue whenever I sell 7,000 items. Again, feel free to fast forward. So if you don't want to watch me working the problem. So I plugged in the 7,000. I'm going to punch it on my calculator. 7,000 squared. It should be 49 with 6 zeros times the 0.001. So this is going to be negative 49,000 plus, and this is going to be 7,000 with an extra zero. So 70,000. Okay. And subtract that from 70,000 and I get 21,000. Okay. Now, my number was negative because I actually did a positive 49 minus a 70, but you know, if you do 70 minus 49, you're going to get 21,000. Okay. So, what are we doing here? We plugged in 3 different numbers. What if I sold 2,000 of these items? Well, of these headphones, then I would make $16,000. What if I sold 5,000? Then I'd make $25,000. That's revenue. That's not profit. What if I sold 7,000 of them? Well, then I'd make 21,000. Just looking at those 3 numbers, revenue, money in, most people would want to maximize their profit or their revenue. So they would say, oh, 25,000 is the most. We're actually going to do something a step farther because we're going to look at profit also. But right now we go, ooh, all of these are profit, or I'm sorry, all of these are positive revenues. 16,000, 25,000, 21,000. Okay. So all that looks really good until they say, all right, what about the profit function? Part C. So the profit function, remember, profit is revenue minus cost. Okay. So we need to go back and figure out our profit. They don't give it to me. I'm going to have to find it. So the profit is the revenue function we said was right here. Negative 0.001 x squared plus 10x minus the cost function. And notice I'm putting parentheses because I know it's an entire cost function. I'm going to have to distribute that minus. So the cost function was 7,000 plus 2x. So make sure you put the parentheses because you're going to have to distribute that negative. Watch out for it. All right, we're going to clean this up just a little bit. Negative 0.001x squared. This is 10x. It's going to be minus 2x, so that's plus 8x, and then minus 7,000. Okay, so we've got our profit function, and the question says find the profit function, and then part D, which we did, part D says find the profit at 2,000, the profit at 5,000, and the profit at 7,000. Okay, so now, okay, you found the revenue a minute ago, but remember, that's not the money in my pocket. That's money into the account. I also still have to pay my costs. So what they're saying is, okay, so find the profit at each of these. So we're going to go P of x equals 2,000. All right, plug in 2,000. Put it in everywhere I see an x. And then we're going to figure out how to use our calculators for this. Okay, 2,000 squared times negative 0.001. Okay, that first number is going to be negative 4,000. Okay, plus 16,000 minus 7,000. Okay, so what is that? That's plus 16,000 minus 7,000. Such a glare on that calculator. So, okay, if I created 2,000 of these headphones and I sold them all, then my profit in my pocket after cost would be $5,000. That's not bad. It's a pretty good amount. More than $2 a headphone. Okay, let's keep going. The profit at 5,000 units. 0.001 times 5,000 squared plus 8 times 5,000 minus the 7,000. That's my function, right? My profit function. So I'm plugging in the 8,000. Let's see. I'm sorry, the 5,000. Let's see what we get. 5,000 squared times negative 0.001. That's a negative 25,000 plus 40,000 minus 7,000. Okay, so let's find out what that number is. Minus 7,000. Okay, so if I sold 5,000 of these units, I could expect to get $8,000 in my pocket as profit. Okay. And then one more of these. What if I did the 7,000? That was the third number they asked me for. Plug it in. Okay. Figure out what the stuff is. 7,000 squared times the negative 0.001. That's a negative 49,000. Oops, I'm sorry. Here you go. And then 8 times 7,000. 56,000, right? Minus the 7,000. All right, so let's see what we got. Minus the 49,000. Minus the 7,000. Uh-oh, what happened? Okay, so This number right here, I'm getting no money back. Okay, no profit in my pocket. So, oh, that was 7,000. Sorry. So even though I sold 7,000 units, all of a sudden, like it looked like it was going so well, right? We sold 2,000, we had 5,000 profit. When we sold 5,000, we had 8,000 profit. But all of a sudden, when we went to 7,000, these numbers end up not making sense. All of a sudden, it's zero. So what the heck's happening here? And the idea here is, let's look at our actual functions and see what's happening. The idea here is basically my cost function has suddenly caught up with my revenue function. That's what's up. So I'm not making any profit here. Yikes. So as a company, would it make sense for us to create 7,000 headphones and start to sell them? No. So the cost would be exorbitant. And that's what we want to make sure we know is what's going on. So let's look at these functions that we had. We had cost function was 7,000 plus 2x. And the revenue function was negative 0.001 x squared plus 10x. Okay. So let's talk about them real quickly and see what's going on. This guy right here is a straight line, right? He's linear and he's got an upward slope. He's positive slope. So he looks like that. Okay. This guy right here is a parabola, but he's negative. So he's facing upside down, right? He's a frowny face. Okay. So basically what's happening here is at some point, the cost function is catching up with the revenue function. So it's not worth it for me to make the 7,000 items. So let's see what this looks like. In the cost function, the first one here, I'm going to go 7,000 plus 2 times the x. And for the next one, I'm going to go negative 0.001 x squared come out of the exponent plus a 10x. Now, I'm going to say this calculator is on my standard window, and that means that it's a 10 by 10 window. Sorry, it goes from negative 10 to positive 10 on both the x's and the y's, and we're dealing with really big numbers here, right? So we plugged in the number 2,000 for the profit function. We got back 5,000. In the revenue function, we plugged in 7,000. We got back 21,000. So these are a lot bigger than negative 10 to positive 10, right? So when I push graph here, I expect to not see much. And indeed, it doesn't even look like anything. Oh, we got a part of the straight line going on here. Or, oh, it's probably part of the parabola, actually. So, because where does this straight line cross? Way up here at 7,000, right? So I'm going to cheat just a little bit. I'm going to do zoom, and there's a number 10 way down here. You can't see it. You could hit just 0. Zoom fit. That gives me a little bit of a thing. It's really not very good. Okay, so let's actually pick a window that we like. So for instance, I'm looking here, my X values are only going from -5 to +5. I know for sure I want to go up to more than 7,000, right? So I'm going to go 8,000. And instead of it counting by ones, that's what the X scale means, I'm going to make it count by, like, say 1,000, because it's pretty big numbers, right? And the Y-min, the minimum value here, I don't really care about that. We can say like -10 or something like that, because we're not doing negative Y values, right? Probably not wanting negative revenue. But my Y max here, I know I went up to 21,000 here. I went up to 25,000 when I put 5,000 in. So I'm going to go up to 30,000. Like, I need some big numbers here. And again, my scale, I'm going to go by thousands because it's really big. So let's see if that's any better. There we go. Okay, so you see what's happening here? When we're looking at this revenue function, revenue is going up, 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 and then it starts coming down, right? Where we're seeing at that 7,000 units is right here, where my revenue and my costs are the same. Like the cost function finally caught up with the revenue. That's what I was saying. Okay. Where we're seeing the more profit is back here, where the gap between these two is bigger. Okay. So the revenue is higher while the cost is smaller. That gives me my most amount of profit. That's why whenever I plugged in the profit function, 5,000, I get the number 8,000. If you know a little bit about your calculator, you can do more stuff like with this. Like I can trace this thing and I can see where, okay, it looks like the biggest gap is somewhere around in here. Okay. That's around the 4,000, the 5,000 mark. And you can trace this all the way over. If you know how to do intersections and stuff like that, feel free. But whenever I come way over here, look right there. Oh, excuse me. Look right there. It goes from 69,000. Sorry, 6,969. It's above the line. And then when I just arrow over one, it's 7,029 and it's below the line. So clearly they crossed there. Okay. So that's the idea of what's going on here. So sometimes, even though you made more revenue, that's what we're seeing here at the $7,000 or 7,000 units, right? When we made 7,000 units and sold them, we made $21,000, but my cost was so high there. It's just catching up to the revenue function that I basically spent out all of what I would have made. There's no profit there. So you probably want to be somewhere back here, like making and selling around 4,000 or 5,000 units, because that's where the gap was the biggest between the revenue and the cost. That's what's going on there. Okay. All right. So, one more little thing about this. You could, of course, find the marginal profit, which is the profit for one more item. You could find the marginal revenue, that kind of stuff. I just want to do one of those. I'm going to look at the part E on this example said find, it's asking me to find all of them, but I'm going to find the marginal revenue. And it gave me all three of those again, but I'm going to do 5,000 because I have a feeling 5,000, the revenue is starting to come back down, right? Okay, so let's see what that looks like. Revenue, our prime is multiply this 2 out in front, negative 2 times 0.001 is 0.002. It's an x, subtract 1 from the exponent, it's x to the first. And then remember, whenever I have like a 10x here and it's x to the first, technically what I'm doing is multiplying that 1 out in front. 1 times 10 is 10. And then subtracting 1 off of that exponent. But what's 1 minus 1? It's 0. And that becomes x to the 0. And so that's just 10 times a 1, right? Anything to the 0 power is a 1. So literally, whenever you see some number like 5x or 10x or something like that, and you're taking the derivative, you literally come away with just the coefficient. And you'll see that if you do enough of these examples. Okay, so here's this guy. I'm going to plug in 5,000 into the revenue function. Okay. What's the revenue there? Where did my calculator go? Negative. Uh-oh. Looks like my battery's starting to die. Negative 0.002 times 5,000. Okay. Negative 10 plus 10 equals. So we're looking at that marginal revenue there. We're looking at the 0 going on. Okay. So what that means is the revenue coming up for the next guy, the revenue I'll make for the next guy was negative 10 plus 10. It was 0. So that was where that revenue maxes out here, and it turned around and started coming back down. That's exactly what's happening there. All right. Okay. That's it for marginal analysis is what it's called in your book. That's the next section of your homework. If you have questions, let me know. Otherwise, I'll just say good luck.